Hello. I wanted to introduce the continuity equation. That's a strange phrase, the continuity equation. Continuity implies that something's continuous, something's not changing. What we're talking about specifically is the flow rate of a liquid through a tube. Um, in fact, if we picture a tube flowing along and maybe it has a constriction in it. If there is a velocity of flow here, what happens in the narrow section? Well, a lot of people would think, oh, it's constricted, it's going to slow down. But if we have 10 gallons per second, or maybe let's say 1 gallon per second, flowing through this part of the tube, well, if the flow rate here is less than a gallon per second, that kind of means this is getting backed up and it's no longer flowing at 1 gallon per second. So in fact, the assumption here is that there is also 1 gallon per second flowing through this section of the tube. That is describing the continuity equation. The volume flow rate stays the same unless there are branches where some of the fluid can go. If there was an offshoot right here, well, then of course some of the 1 gallon per second is going that way while the rest is going that way. And that's not what we're talking about here. So I'm going to say 1 gallon per second. So let's see, if I wanted to write 1 gallon per second as an equation, 1 gallon is a volume. I could say cubic meters if I was thinking about the metric system. 1 gallon per second is a volume over a time. We often use the symbol volume. Q means flow rate. So volume flow rate is volume over time. That's not an equation sheet. That's just a concept. It's kind of nice to know. But what is volume for a tube flowing by? Well, we could think of volume as being, say, volume of a tube. That would be like, let's say, a cylinder. Could I say base times height? Base times height, or base times length, or area times length. So that's base times height, area times the length instead of the height because it's horizontal. Over time should be the same concept. And of course, now if I look at this and say, all right, the length that this water travels in a certain amount of time, that's like distance over time. That's a velocity, a speed, isn't it? Could I say area times velocity? In fact, volume flow rate is measuring volume over time. But another way to think of that is the cross-sectional area of the tube times the velocity of the liquid flowing through that tube. Now, I already mentioned the idea that it's 1 gallon per second here and 1 gallon per second here, which is saying that it's volume over time at the beginning equals volume over time at the end, which means area times velocity equals at the beginning equals area times velocity at the end. So what you'll find on your equation sheet is that area 1 velocity 1 equals area 2 velocity 2. That's a lowercase v for velocity, not a capital V for volume. But that equation is the continuity equation that you're going to find on the equation sheet in your fluid section. It says the area times velocity in this section of the hose equals the area times velocity in this section of the hose. Now, to take that a step farther, tell me about the cross-sectional area right here. Well, it's quite small, right? So what does that mean? If the area in the second part is very small, what does that mean about the velocity? Well, to make this equality true, if we made one part smaller, we don't have to make the other part bigger. In other words, the smaller section has a faster velocity. The water speeds up when it gets through this section. Now, we all know this because you've played with a garden hose and you know what happens when you squeeze your thumb over the end, right? You're narrowing the velocity, narrowing the area, and we know that it speeds up the velocity, makes the water shoot out faster, doesn't it? That's the continuity equation in action right there. Where else might that apply? Well, if you've ever been canoeing down a river, you know that there are sections where the river gets really narrow. What do we call that section? It's called the rapids, because what happens when the river gets narrow, it speeds up and you're going really fast launching through the rapids. Later on, when the river widens out, it slows way down. Excuse me. Um, Doctors are concerned about your arteries. If there is a place in your arteries where there is all sorts of plaque built up on the side, that can force the velocity to be very large. And that's certainly a change that's going on inside your body as you build up plaque on in your arteries. We don't want that to happen. Who cares? Who cares how fast water is flowing through a hose? Well, um, if I worked for a bottling company, Pepsi bottling company or Coca-Cola bottling company, I guarantee they're really uptight about how fast the water is flowing through certain hoses and filling certain bottles. They absolutely need to know the volume flow rate, the area times velocity, so they can figure out how long it's going to take to fill up the bottles. They, in truth, are probably going to write area times velocity equals volume over time because they want to know how long it's going to take to fill a 2-liter bottle, for example. Well, that's in a hose, but what if we go large scale? What about a river? Do we care the flow rate along a river? You may or may not, but somebody does because there are barges that are wanting to go up and down the river, and they need to know how fast is the flow rate down this river. If it's too low, the barges are going to hit the bottom of the river, and they can't be in the river. So we try and keep track of the volume flow rate of the Missouri River and the Platte River. In fact, you used to be able to look it up on Sundays in the World Herald. They publish the volume flow rate of the Missouri River. They tell you how many gallons of water are flowing down the river at any moment in time. Now that seems a little complicated. What do they take a big graduated cylinder in the Missouri River and try and figure out the volume flow rate that way? How many gallons are flowing each second? No, they do this. They figure out the cross-sectional area times the velocity. Now, the World Herald isn't doing that. The Army Corps of Engineers is doing that. The Army Corps of Engineers is a branch of the Army. It is their job to make sure that they manage the dams and the water flowing down and through our rivers. If they overdo it and let too much water down, they can flood things below. If they don't let out enough water, the dams full up, and then what happens when there's a huge inrush of water? There's no more room for them to store that water, and there's, again, floods. So the Army Corps of Engineers has they have a station up north of Omaha, very near my house, off the Mormon Bridge. And from their station, they can see the pillars supporting the Mormon Bridge. Those pillars are sticking up out of the water. Say the lay of the land is like this. There are pillars sticking up out of the water on each side, and there are markings on those posts so that they can tell the depth of the water at that location. So they know how high the water is. Of course, they know the lay of the land down below, and they can calculate the cross-sectional area of that thing. How do they get the velocity? Oh, that's easy. You toss a stick in the water. Watch how long it takes to go 100 meters, and you've got your velocity. With area times velocity, they're able to calculate the volume flow rate. Then they can say, let's think about units here. Area would be in square meters. Velocity would be in meters per second. And we get cubic meters per second. Which is a volume flow rate. That's a volume over a time. Of course, you convert that into gallons per second if that's what you're dealing with. So the Army Corps of Engineers absolutely does this. They can tell you the volume flow rate of the Missouri River or the Platte River or basically any other river around the country. It's their job to be responsible for what those are all about. Farmers might care about irrigation. They are totally worried about the volume flow rate through the pipes that lead to their crops getting watered. So there's some examples, a bunch of examples of why we care about this idea of the continuity equation, area times velocity. This is what's on the equation sheet. I think it's really nice to know that those units give us volume over time units so that this volume over time is really equal to these two pieces. All right, hopefully that helps. Have a wonderful day.